The dream of human colonies on Mars has transitioned from science fiction to a tangible goal, driven by ambitious plans from organizations like SpaceX and NASA. Establishing self-sustaining cities on the red planet or even the moon involves overcoming immense challenges: radiation, extreme temperatures, limited resources, and psychological isolation. By examining SpaceX's vision for a Martian metropolis and NASA's Artemis program for lunar outposts, we can piece together what life in these extraterrestrial colonies might entail, from habitat design to societal structures, and glean lessons for humanity's multi-planetary future. The vision for Martian colonies, SpaceX, led by Elon Musk, envisions a thriving Martian city housing 1 million people within a century. The cornerstone of this plan is the Starship, a fully reusable spacecraft designed to transport up to 100 passengers and massive cargo loads to Mars. Musk's strategy hinges on affordability, reducing launch costs to make frequent trips feasible. Starship's stainless steel construction and methane oxygen engines enable it to refuel on Mars using in situ resource utilization, ISRU, where carbon dioxide from the atmosphere and subsurface water ice are converted into fuel. This self-sufficiency is critical, as Mars's distance, averaging 225 million kilometers from Earth, means supply missions are limited to every 26 months during optimal launch windows. NASA, meanwhile, focuses on incremental steps. Its Artemis program aims to establish a lunar base by the late 2020s as a testing ground for Mars. The Lunar Gateway, a small space station orbiting the moon, will serve as a staging point, while surface habitats will test technologies like 3D printed shelters and life support systems. NASA's Mars roadmap, including the Mars Sample Return mission, prioritizes robotic exploration to study the planet's geology and habitability before crewed missions in the 2030s or 2040s. Both organizations agree, colonies must leverage local resources and robust infrastructure to survive. Habitat design. Mars' environment is hostile. Surface temperatures swing between 140 degrees C and 20 degrees C. Atmospheric pressure is less than 1% of Earth's, and cosmic and solar radiation pose constant health risks. Habitats must be airtight, insulated, and shielded. SpaceX proposes pressurized domes made from advanced materials like carbon fiber or regolith-based concrete, constructed using autonomous robots. These domes could house entire communities with interconnected modules for living, farming, and research. NASA's concepts include lava tube shelters, natural underground caves formed by ancient volcanic activity that offer inherent radiation protection. Radiation remains a primary concern. Mars lacks a magnetic field, exposing colonists to DNA-damaging cosmic rays. Shielding solutions include piling regolith, Martian soil, over habitats or using water-filled panels, as water effectively absorbs radiation. SpaceX's Starship could serve as temporary shelters during early missions, while NASA's deep space habitat designs incorporate multi-layered walls with hydrogen-rich plastics. Both agencies emphasize modularity, allowing habitats to expand as populations grow. Life support systems are equally critical. Closed-loop systems will recycle air, water, and waste. NASA's Environmental Control and Life Support System, ECLSS, tested on the International Space Station, filters carbon dioxide and generates oxygen via electrolysis. On Mars, ISRU will extract water from ice deposits vital for drinking, agriculture, and fuel. SpaceX plans to deploy solar panels and small nuclear reactors for power, as Mars' thin atmosphere weakens solar efficiency. These systems must be redundant to prevent catastrophic failures in an environment where resupply is years away. Sustaining life, food, water, and health. Food production on Mars requires innovative agriculture. Hydroponics and aeroponics, which grow plants without soil, are ideal for space-constrained habitats. NASA's veggie experiments on the ISS have grown lettuce, radishes, and kale in microgravity, using LED lights to mimic sunlight. On Mars, greenhouses pressurized with Earth-like atmospheres could cultivate crops like potatoes, beans, and wheat. Genetic engineering may yield radiation-resistant, high-yield plants. SpaceX's vision includes large-scale farming domes to feed thousands, potentially supplemented by lab-grown meat to reduce resource demands. Water is abundant but locked in ice. NASA's MOXIE experiment, part of the Perseverance rover, demonstrated oxygen production from atmospheric CO2, and similar technology could extract water vapor. Subsurface ice, mapped by orbiters, can be mined and purified. However, recycling will be paramount. Colonists may recover up to 98% of water from urine, sweat, and respiration, as tested in NASA's water recovery systems. Health challenges are multifaceted. Radiation increases cancer risks, requiring advanced medical facilities with diagnostic tools and telesurgery capabilities, given Earth's communication delay of up to 24 minutes. Microgravity during transit and Mars' 38% Earth gravity may weaken bones and muscles, necessitating exercise regimens and possibly artificial gravity habitats. Psychological health is equally vital. Isolation, confinement, and monotonous landscapes could trigger depression or conflict. Society and governance. A Martian city will need a societal framework. SpaceX's vision leans toward a libertarian model, with Musk suggesting a direct democracy where colonists vote on laws via blockchain-like systems to ensure transparency. NASA, tied to international treaties like the Outer Space Treaty, emphasizes cooperative governance, potentially involving multiple nations. Both face questions of autonomy. Will Mars be an Earth dependency or an independent entity? Legal frameworks must address property rights, resource allocation, and criminal justice in a frontier environment. Cultural diversity will shape colonies. Early settlers, likely scientists, engineers, and medical professionals, will come from varied backgrounds. SpaceX aims to make migration accessible to non-specialists, fostering a heterogeneous society. Education systems, possibly virtual, will train children in STEM and Martian survival skills. Art, music, and sports adapted to low gravity could forge a unique Martian identity, countering homesickness. Economic systems are speculative. SpaceX envisions a resource-based economy initially, with trade in water, oxygen, and fuel. Long-term, Mars could export rare minerals or intellectual property like scientific discoveries. NASA's focus on research suggests early colonies will prioritize knowledge over commerce. Challenges and future prospects. Technical hurdles abound. Dust storms lasting months can clog solar panels and erode equipment. Communication delays require autonomous systems and AI to handle emergencies. Human reproduction on Mars is unstudied. Radiation and low gravity may affect fetal development, raising ethical dilemmas about raising families. Socially, inequality looms. SpaceX's ticket model, even if affordable, may favor wealthier nations or individuals, echoing Earth's disparities. Governance disputes could fracture small colonies where cooperation is survival. International treaties must evolve to address Martian sovereignty and resource rights. Yet the potential is transformative. Martian colonies could drive technological leaps like fusion energy or advanced AI benefiting Earth. They may inspire global unity as humanity rallies around a shared frontier. Conclusion. Life on Mars will demand resilience, ingenuity, and collaboration. SpaceX's vision of a sprawling city contrasts with NASA's cautious lunar prelude, but both converge on key principles: leveraging local resources, building robust habitats, and fostering human adaptability. These colonies will be humanity's ultimate experiment, testing whether we can thrive beyond Earth. The lessons, technological, ethical, and societal, will redefine our species, whether we remain tethered to Earth or become truly multiplanetary. As Musk has said, it's about believing in the future and thinking that the future will be better than the past. Mars is that future's proving ground. If you enjoyed this video, make sure to subscribe to this channel for more content. Thank you.